What if the bright comets streaking toward our sun aren't natural at all, but engineered machines? In late 2025, astronomers were stunned when a massive interstellar visitor appeared out of nowhere, so bright and enormous, it made every comet before it look like a toy. Officially, it's been named SWAN R2. But to scientists who've studied its bizarre behavior, this object doesn't act like a comet. It behaves more like a fortress, something built, not born. And here's where things get strange. SWAN R2 is arriving at nearly the exact same time as another mysterious object, 3I/Atlas. Two separate cosmic bodies from opposite directions of the galaxy, both converging on our sun within days of each other. The odds of that happening by chance? Almost impossible. So the question is unavoidable. Are these visitors connected? Are we witnessing a natural coincidence? Or the quiet arrival of technology older and more advanced than anything we've ever imagined? On September 12, 2025, a faint signal appeared on the SOHO spacecraft's SWAN instrument, a detector designed to track the solar wind. At first, it looked like just another comet, but within hours, astronomers realized this wasn't ordinary. This thing was huge. 2 days later, Australian comet expert Michael Matiazzo captured an image that left the scientific community stunned. A dazzling tail stretched across the sky, 2.5 degrees long. To put that into perspective, that's the width of 5 full moons lined up side by side. Compared to it, 3I Atlas, the previous interstellar visitor, suddenly looked small, fragile, almost insignificant. When the International Astronomical Union officially named it C2025 R2 SWAN, the announcement hit like a thunderclap. Because this wasn't just another comet sighting, it was another interstellar arrival. And not just bigger, but stranger, arriving on a trajectory so precise it forced scientists to ask, what exactly is happening in our solar system right now? But the real shock wasn't the discovery itself. It came when scientists started comparing SWAN R2 to 3I Atlas and realized they might not be looking at simple comets at all. At first glance, SWAN R2 looked like a comet on steroids, bigger, brighter, and far more dramatic than anything seen before. But when astronomers placed it side by side with 3I Atlas, the similarities ended fast. 3I Atlas had already shaken scientists to the core. Instead of the usual icy ball, scans revealed a body made almost entirely of nickel, with none of the expected iron. Even stranger, its tail wasn't the random spray of melting ice. It behaved like exhaust, steady, focused, as if it were engine thrust. And inside, instruments detected what looked like a 10-gigawatt nuclear core. Not natural, not random, designed. But if 3I Atlas was shocking, SWAN R2 made it look like a toy drone, wrapped in a silver plasma shield, dwarfing Atlas in size and brightness. This thing radiated energy levels no natural comet should ever emit. One scientist described the comparison like this: Atlas was a scout, SWAN was a warship. And the closer researchers looked, the harder it became to dismiss. The question shifted from what is this to who built this and why send it now? But it wasn't just the technology that left scientists speechless. It was what they discovered about SWAN R2's orbit. The deeper scientists probed into SWAN R2, the less it resembled anything natural. Its movements weren't random, and its glow didn't behave like a ball of ice boiling in the sun's heat. Instead, it pulsed, controlled, deliberate, like a machine, fine-tuning its engines. Avi Loeb's team detected thrust pulses so precise they could only come from an advanced propulsion system. They weren't chaotic outbursts of gas, but measured bursts, tiny nudges that shifted the trajectory with uncanny accuracy. And then came the core. If 3I Atlas's 10-gigawatt reactor was already terrifying, SWAN R2 pushed the limits of imagination. Its plasma core was measured at over 10,000 gigawatts every single second, a power level Loeb compared to the energy of colliding black holes, somehow scaled down and contained inside one object. Even its defenses seemed impossible. Around its nickel-cobalt hull stretched a plasma shield, not passive protection, but a living electromagnetic barrier strong enough to bend solar wind itself. No comet could do this. No rock drifting through space could bend radiation like armor. At that point, astronomers stopped asking if SWAN R2 was natural. The evidence suggested something else entirely, advanced engineering. But the real shock didn't come from its power, its shield, or its tail. It came from the orbit, and what that orbit revealed about just how long this visitor has been coming back. If SWAN R2 were just a one-time flyby, scientists might have written it off as a spectacular coincidence, but its orbit shattered that comfort. NASA and JPL calculations revealed SWAN R2 wasn't just passing through, it comes back on a 22,554-year cycle. In other words, this isn't its first visit, and it won't be its last. The last time SWAN R2 swept past the sun was at the end of the last ice age, right around the period when humanity began building monumental structures and gazing at the stars with mathematical precision. Think about it. The sudden rise of agriculture, the first calendars, the mysterious alignments of pyramids with Orion. Were these just random leaps or echoes of a sky-shaking event our ancestors witnessed? Some researchers argue that ancient builders may have encoded SWAN's return into stone. The shafts of the Great Pyramid pointing to Orion, the star maps etched into megaliths, the obsession with solar cycles. To them, these weren't just cultural artifacts. They were warnings, or perhaps instructions, passed down from a time when the last great visitor lit up the heavens. And if that's true, then SWAN R2's orbit isn't just a curiosity. It's a schedule, a cycle written across both the cosmos and human history. But here's the real question. Why return on such an immense timescale? What could possibly require a 22,000-year appointment with our sun? If SWAN R2 really is an engineered machine, then the next question is obvious. What is it doing here? One theory suggests routine maintenance. Imagine an ancient network spread across the solar system, hidden probes buried in asteroids, silent stations under polar ice, or beacons orbiting unseen in deep space. SWAN's job could be to refuel, recharge, and update them. In this view, its vast power core isn't a weapon, but a service engine, harvesting plasma from the sun like a pit stop every 22,000 years. But another possibility is darker. If 3i Atlas was a scout, SWAN R2 could be the heavy lifter, arriving to collect its data, retrieve its power core, or even destroy it before humans can get too close. Some researchers even speculate the two objects might not be allies at all, but rivals, ancient machines from opposing civilizations, converging on our sun to fight over a resource far greater than gold or oil, the sun's raw energy itself. And then there's the most unsettling thought of all, that SWAN R2 isn't here for silent upkeep or cosmic rivalry, but because of us. For Avi Loeb and his team, the timing was too precise to ignore. 3 extraordinary objects in less than a decade. Oumuamua in 2017, 3i Atlas, and now SWAN R2. After millennia of silence, why would the universe suddenly deliver 3 interstellar visitors, back to back? Loeb's answer was simple and unsettling. Maybe it wasn't random at all. Maybe it was a reply. For over half a century, humanity has been broadcasting its presence to the stars. Radio and television signals, powerful radar pings, the Arecibo message, even the golden record strapped to the Voyager probes. Tiny pieces of our culture, drifting outward in a growing bubble of noise. By now, that bubble has washed over dozens of nearby star systems. If someone or something was listening, they've heard us. And if SWAN R2 is truly a machine, then its timing feels less like coincidence and more like a response. Think of the sequence. Oumuamua, dark and silent like a first scout, then Atlas, a metallic probe with a nuclear heart, and now SWAN R2, a fortress wrapped in plasma with power rivaling black holes. Step by step, each one escalates. So the terrifying question is this: did our own signals bring them here? And if so, what do they want from us? Something else about this whole story is almost as loud as the objects themselves: the quiet. Despite jaw-dropping data, official channels have been muted. Major space agencies and government offices have offered little more than carefully worded statements, or nothing at all. That absence of clarity speaks louder than press releases. Why the silence? One possibility is simple caution. Officials may be withholding details while teams verify measurements and cross-check instruments. But another explanation feels darker and rawer. When agencies stay quiet in the face of extraordinary evidence, it can look like a choice to limit public alarm or to keep control of an uncertain narrative. Reports claim internal briefings took place, and scientists exchanged urgent messages, yet the public record stayed sparse. If true, that pattern raises a question. What happens when a discovery is too destabilizing for institutions to release in full? Who decides what the public has a right to know? Silence can also be strategic. Governments may be buying time to coordinate international responses, build consensus, or evaluate risk. They may fear causing panic, or they may be guarding information for reasons of national security. All of those are plausible, and all of them leave the public in the dark. But intentional quiet breeds its own kind of speculation. When official voices withdraw, online communities rush in to fill the gaps. Rumors spread, experts spar publicly, and conspiracies find oxygen. The result is a messy, emotionally charged conversation where facts and fears blur together, which leaves us with one final choice: trust the slow, careful work of vetted science and institutional caution, or treat the silence as its own piece of evidence, a sign that something far bigger may be unfolding.